Hey guys, welcome back. For lesson 5.2, we're going to talk about writing equations in standard and point slope form. This is going to be a little bit of a long video, but it is only a one-day lesson, so you might want to take really close notes. First thing is we are going to write equations in point slope form. We are not going to create and identify equations of parallel or perpendicular lines. We're not covering that this year. Okay, so the first thing we have here is some vocabulary and what is point slope form. Well, here's the equation for point slope form, and you can see that it's a non-vertical linear equation that's written in that form. It uses a single point, so you see I have it in blue there, a single point, which is y1, x1. Now that point has to be on the graph, and it's got to have a slope of what's in red here. The x and y values that are here, they stay in the problem. We don't remove them. Those are the variables that are always there. The parameters of this problem are the y1, the m, and the x1, which comes from a single point and a slope. Next vocabulary word is standard form, and this should not be new to us. We've seen this already. It's in the form of ax plus by equals c. And what's important about this is the a, the b, and the c values, which are these three numbers here, have to be integers. A and B cannot both be equal to 0 at the same time because you wouldn't have a line at all if they were both equal to 0. And A is non-negative, and some people get confused on this. When we say A, which is this one up front, is non-negative, the B and the C can be negative. It's just that A cannot be negative. And it should be written such that AX is always written first because standard form is descending order of degree, and then after that it's in alphabetical order. So we should have it written with the AX first. I have a few examples here. The only one that's standard form is the first one, and you'll notice it's got integers for all three. The AX, which is 4x, is written first. There's no zeros for x and y. The second one, not standard form. What caused it to be not standard form? Well, this right here, which is the minus or the negative 3x, that's not allowed to be negative. The second one, what caused it to not, or the third one here, what caused it to not be standard form is can't have a fraction. And the last one, what caused it to not be in standard form is you can't have decimals. So you have to clear all those out. Okay, so the first thing I want you to know about point slope form is it comes from the slope formula. So you can see we have the slope formula here, and notice that it requires 2 points. That's why we have x1, y1, x2, y2. We have 2 points. If we were to, let's say, get rid of one of those points, like this, so you notice down here we don't have any subscripts on those, and then we were to use the symmetric property to rewrite it so that m is on this side and the ratio is on the other side, and of course we just removed 1 point. So now we have 1 point and a slope, which really kind of falls in pattern of point slope form. But we make it look slightly different, and that is we get rid of the denominator on this side right here, and the way we do that is we multiply both sides of the equation by x minus x1. When I multiply this other side, x minus x1, what happens is the x minus x1 on the left cancels, leaving just the y minus y1, and then the m times the x minus x1, we just write it right next to it as if it's waiting for the slope to distribute. Okay, so we multiply both sides by the x minus x1, which is the x coordinate of that 1 point, and that right there is point slope form. It's one of the easiest forms to start in, and it can be transformed into slope-intercept form, and it can be transformed into standard form, which we will see. All right, so for our first example here, they want us to write an equation in point slope form of a line that passes through this point here, which is negative 2, 7, with a slope of negative 3/2, then graph the equation. So we have our point slope form up here. So I'm going to write that without the numbers in there. So y minus something equals something else times x minus something else. So what we're really trying to fill in is what goes here, and what goes here. So we're just changing out these parameters right there. So the parameters that go in there, the y1 goes here. So if we look back, y1 is a 7. So we're going to put a 7 there. The m goes next. Well, the m is our slope. That's at negative 3/2. And then the point that goes here, which is the x1, go back to the only point they gave us, which was a negative 2. And inside there, I'm going to put in parentheses negative 2 because minus a negative 2 would actually give us an x plus 2. Then they did, and this right here is, this is point slope form. That is the actual form. Now you could write it a little differently. You could write y minus 7 equals negative 3 over 2. And inside, instead of doing the minus a negative 2, is just put x plus 2. And they did ask us to go graph this. So what we're going to do to graph it is we're going to graph the point that we see here, which remember, this is like opposite. So its x-coordinate is not 2, it's negative 2. Remember, we wrote that out from the side. That's way over here on the side. And the y-coordinate is 7. So if I graph this, I go to negative 2, 7. So I'm going left 2 and then down 1, 2, 3, 4, 5, 6, 7. So our first point on the graph is right there. So it's a lot like graphing in slope-intercept form, except now we don't start at the y-intercept. We start at some other point on the graph. Now to find the next point, I'm going to apply the slope of negative 3 halves. So I'd want to go down 1, 2, 3, and over 2. My next dot will be right here, and I'm running out of space, so I got to reverse that. I got to go up 1, 2, 3, and left 2, and put my next dot. Then I got to go up 1, 2, 3, and left 2, and then put my next dot. I'm going to do it one more time. 1, 2, 3, and over 2. And then I'm going to erase the auxiliary lines that are helping me out here, and then just draw the best line that I can. So my line would look something like this, and it looks like I missed one of my lines there. There we go. And that would be the line drawn from point slope form. So the biggest challenge here is when you go to find the point for x and y from point slope form, you're always doing the opposite of what's here for x and the opposite of what you see here for y, because the original formula comes from the slope formula, which is always a subtraction. For this example, they want us to write an equation in point slope form from a line that passes through the given points. So they gave us 2 points in this context. So with 2 points here and here. And in order to draw this in or write this equation in point slope form, the first thing we have to calculate is the slope. So you might want to write that down on your foldable in 5.2. When writing in point slope form, you must use or find the slope first. So I'm going to write my points out as 2, negative 7, 6, negative 3, and I'm going to subtract them. And negative 7 minus negative 3 is going to give me a negative 4, and 2 minus 6 is going to give me a negative 4. So it looks like the slope of my line here is just 1, so m equals 1. Now to write this in point slope form, all I got to do is drop in a point, which is the x1, y1, and the slope. And I have 2 points. It does not matter which point I choose. I'm going to choose to put in the bottom one, which is 6, negative 3. So that's the point I'm going to use. But you could write it in either way. And actually, I'm going to write it both ways. I'm going to write with both points. So I'll write them right next to each other. So y minus, and the y value here is a negative 3. So minus negative 3 equals, the slope is 1. So 1 times x minus the x value is 6, and then I'm writing above this again using this point. So y minus negative 7 is equal to 1 times x minus 2. And these two equations, they look different from each other, but if I were to simplify them into slope-intercept form, you'll see that they are exactly the same equation. Okay, for this next one, they ask us to write the equation they already gave us, which is right here. This is in point slope form, but they want us to write it in slope-intercept form. Now, slope-intercept form only takes 2 steps. Okay, so our 2 steps, step 1 is to distribute. So I'm going to distribute here and here. So I bring down the y plus 4, and that's going to equal negative 2x and a positive 12. And then the second step is to subtract the 4 from both sides so we can isolate y. So y is going to equal negative 2x, and 12 minus 4 is going to give us a positive 8. And this right here is the slope-intercept form. You can see this is actually a very easy conversion. All right, this example is a word problem, and they do want us to write an equation in point-slope form. Usually when I do word problems, I will start off in point-slope form, but I don't leave them in that form. I'll write them in slope-intercept or standard form. But we are going to leave this one in point-slope form. Nadia's book club is ordering new novels. She knows that the total cost of 5 books is $61.25 and 15 is $159.75. Write an equation. So remember, the first thing we've got to find is the slope. So I'm going to write this in the traditional way. So I'm going to do this ordered pair right here. So this would be 15, 159, and this will be another ordered pair right here, which is 5 and 61. So 159.75 minus 61.25. So this is the change in the y values over the change in the x values, minus 15 minus 5. And this is going to give us 9850 over 10, which means our slope is going to be 9.85. And now all I got to do to put it in point slope form is choose either this point here or this point here to drop it in. Now, since the numbers on this side are smaller, I'm going to use those, but you could do the other one. So it's going to be y minus, now if I look back up, the y value up here was 6125, so minus 6125. And that's going to equal, now the next thing that comes in is the m value, the slope, which we said was 985, 9.85. And then times x minus, and the x value up here was 5 books, so minus 5. And there's our equation. This next example asks us to take the equation that's here in point slope form and write it in standard form. The conversion to standard form is a little bit longer than the conversion to slope-intercept form because we're going to actually go to slope-intercept first. So the first thing I would do is distribute. So negative 2/5 times x is negative 2/5 x. And negative 2/5 times 3 is going to be negative 6/5. And to make this problem a little bit simpler, I would probably clear all the fractions out at this point. So I'm going to multiply everything by 5 on both sides. So I distribute on this side, I get 5y minus 5 equals, when I distribute here, I get a negative 2x. When I distribute here, I get a negative 6. Now, standard form is ax plus by equals c, so I've got to get the x and y values together. So I'm going to add the 2x right here on both sides, so plus 2x plus 2x. And that's going to give me 2x plus 5y minus 5 equals negative 6. And I'm almost there. I've got the x and y together, but I've got this other point, this other minus 5. That's a constant. That's supposed to be on the other side, so I need to add 5 to both sides to get that out of there. So now I'm left with 2x plus 5y equals, and negative 6 plus 5 is negative 1. And this right here is my standard form. Okay, in this last example, they're asking us to write in standard form of the line that passes through those 2 points, but we're going to drop it into point slope form first and then convert it into standard form. But the first thing I always have to do if I'm given 2 points is find the slope. So the slope is going to be negative 11 minus negative 4 over, now I started with this point, so that means I got to start with negative 6 minus 8, and that's going to be a plus 4 right there, which is negative 7 over negative 14, which is positive 1/2. So my slope is positive 1/2. I'm going to drop that into the formula in place of m, so 1/2 is there, x minus, y minus. Now I got to choose which point I want to use. Well, I like to use the points that are closer together or smaller, which would be this one, 8 and negative 4. So the y value there is negative 4. So minus a negative 4, and then minus 8 on the inside, and then distribute here. So the left-hand side, I'm going to simplify a little bit. Minus a negative 4 is really plus 4. And then a negative 1/2 times x is 1/2 x. And then 1/2 times negative 8 is negative 4. I'm going to clear my fraction next. So I'm going to multiply both sides by 2. 2 times y is 2y. 2 times 4 is 8. When I multiply this side by 2, a half times 2 is 1x, which means it's just x. And then 2 times the negative 4 is negative 8. Now I want to get my x on the other side, so I'm going to minus x on both sides. I have a negative x plus 2y plus 8 equals negative 8. Now I want to get rid of this 8 by subtracting 8 from both sides. I'm going to have to do some more work out to the side, so I have negative x plus 2y, and then the 8's cancel on the left, and negative 8 minus 8 is negative 16 on the right. Now, most common mistake is to stop here, but remember this leading coefficient is not allowed to be negative, so to fix that, we're going to multiply everything through by a negative 1, which effectively just changes all the signs. You'll notice that everything flips, so this is our final standard form.